The analysis of social factors influencing waste generation in Japan. Background. The understanding of waste generation and the waste reduction is a major issue of solid waste management. To clarify the social and economic factor influencing waste generation is required. Conventionally, there are two assumptions as social and economic factor for waste generation. First, increase in income increases waste generation. Second, big family size decreases waste generation. Literature review. The study of the relationship between social and economic factors and waste generation have been made from more than 30 years ago. Income. There are many research which income increases waste generation, such as wealth and Maruo. But Nakamura insisted there were some cases which income is not positive factor. Family size. Richardson and Havlik insisted family size is the factor which is increasing waste generation. In construct, Abe used family size as negative factor. Thus, it is difficult to purpose. This research investigated the impact of the ratio of farmer in addition to those hypotheses. Farmer are low consumption, so third assumption is urban area are lower waste generation than rural area. In order to investigate whether these three hypotheses is correct, this paper already analyzed the different factors that influenced waste generation by multiple regression, namely family size, income, and the ratio of the methodology. This paper analyzed the different factors: income, family size, the ratio of the farmer, that influence waste generation by multiple regression analysis. This research used secondary data from the statistic variable. This data is all 47 prefectures in Japan. The variables of multiple regression are waste generation as the dependent variable, and income family size ratio of farmer as independent variable. This figure shows model summary. The R square is 0.261. It shows 26.1% of all waste generation can explained by those factors. Therefore, there are still many factors for waste generation besides those factors. This figure shows the result of ANOVA. The significant probability is 0.004. P-value is statistically significant at the 95% confidence level. The significant probability is under 0.05. Therefore, this analysis is significant. This figure shows the result of coefficient. From this data, we can know the regression equation. The regression equation is y equals 399.771 plus 0.01 by x1 minus 24.861 by x2 minus 1.63 by x3. Y is waste generation, x1 is income, x2 is person per household. X3 is ratio of farmer. This equation shows income is positive factor and person per household and ration of farmer are negative factors. And the standardized coefficient beta of the ratio of farmer is the highest of those three. It means the ratio of farmer is the highest weight. So the ratio of farmer is the most important factor of those three. Conclusion. This research shows income is positive factor and person per household and ration of farmer are negative factors. The three assumptions are correct in this case. First, income increases waste generation. Second, big family size decrease waste generation. Urban area are lower waste generation than rural area. The ratio of the farmer is important factor for analysis of the factor influencing waste generation. Further research. This research uses the prefecture data, but it is too big as the sample. Therefore, it needs to analyze this research by smaller area, such as the city, town, and village. Thank you.